Imagine, out in the far reaches of our solar system, a frozen world orbits the giant planet Jupiter. It glimmers with icy brilliance against the dark canvas of space, its surface crisscrossed with mysterious cracks and colored streaks. This is Europa, Jupiter's enigmatic moon. While much of our collective imagination is captivated by the rusty plains of Mars, with its promise of domed cities and roving explorers, we tend to overlook Europa, the true hidden gem of our celestial neighborhood. But what if this frozen moon, shimmering in Jupiter's shadow, is the place where humanity's greatest discoveries, and perhaps even the answer to whether we are alone, await us? To decode this problem, watch until the end. A surprise awaits you. Subscribe to the channel now so you don't miss out on valuable knowledge, and join me on the journey of independent scientists. Let's start with the basics. Europa, a speck of light among the stars, has been known to humanity for centuries. Galileo first observed it in January 1610, and for much of our history, it was simply Jupiter's second moon, smaller than our own, seemingly just another barren satellite. But in the mid-20th century, the story began to change. Spectral analysis hinted that its surface wasn't rocky, but instead coated in water ice. Then, in 1979, NASA's Voyager probes delivered the first close-up images, and what they revealed was astonishing. Vast, bright, icy plains, scarred by thousands of dark lines crisscrossing in a giant red lattice. Even more surprising, impact craters were almost nowhere to be found. Why are there so few craters? Why does the surface look as though it's been torn apart, with darker material welling up from below? What mysteries are concealed beneath this glacial shell? The only explanation that makes sense is that Europa's surface is constantly renewed by powerful geological activity, suggesting an internal heat source. And if there's heat, and if the surface is ice, what lies beneath? The answer, as it turns out, is profound. Thanks to gravitational interactions with Jupiter and its neighboring moons, particularly through a phenomenon known as Laplace resonance, Europa is subjected to immense tidal forces. These forces stretch and flex its interior, generating enough heat to keep an ocean beneath the ice in a liquid state. Imagine, below that unbroken expanse of frozen water could be a vast, global ocean. Not just any ocean, but one with more water than all of Earth's oceans combined, possibly as much as 100 kilometers deep. The Galileo spacecraft, which began orbiting Jupiter in 1985, confirmed these theories. Its instruments detected evidence of a salty, liquid ocean beneath Europa's icy crust. This isn't just a puddle trapped beneath the surface. It's an entire planetary ocean, deep and dark, stretching out beneath a shell of ice perhaps 15 to 25 kilometers thick. Why does this matter? Because where there is water, there could be life. Europa's ocean is isolated from the sun's warmth, but it may be heated by hydrothermal vents on the seafloor, just like those on Earth, where life thrives in the dark, sustained by energy from the planet's interior. Compare Europa to Mars, and the difference is stark. Mars is closer, with its own allure. Dusty landscapes, familiar day lengths, and the faint promise of ancient rivers. But Mars is dry, cold, and its water, if any, is locked in polar caps and underground ice. Europa, on the other hand, offers an abundance of water, and with it, the raw materials for air, oxygen and rocket fuel, hydrogen, extracted through simple electrolysis. The possibilities for sustaining a human presence are tantalizing, but Europa is as perilous as it is promising. First, there's the radiation. Jupiter's magnetic field traps deadly belts of charged particles that envelop Europa. Without heavy shielding, a human on its surface would receive a fatal dose of radiation in mere hours, far more than the worst nuclear reactor accident on Earth. Then there's the distance. Europa is roughly 630 million kilometers from Earth at its closest, compared to Mars's 55 million. A journey to Europa would take 3 to 6 years with current technology, making quick returns impossible. Any crew heading there would be embarking on a one-way trip, perhaps for decades. Then there's the greatest physical challenge, The ice. To reach the ocean, explorers would need to drill through up to 25 kilometers of rock-hard, super-cold ice. This is no ordinary ice. It is crystalline, compressed over millions of years, as hard as granite but clear as glass. Even if you could bore through it, the tunnel would try to freeze shut behind you. Every meter would be a battle against the physics of an alien world. If these obstacles seem daunting, they are. Yet, the promise of discovery continues to drive us forward. Imagine future missions, robotic probes that land near Europa's towering ice ridges, drilling heat-propelled cryobots that melt their way down to the ocean, and miniature submarines that swim in the inky depths, hunting for signs of life. NASA's Europa Clipper, launching soon, will orbit Jupiter and make dozens of close passes, mapping the surface and scanning for the best places to search for life. And beyond these robotic pioneers, imagine the first human outposts, bubbles of life beneath the ice, connected by tunnels, powered by tiny nuclear reactors, hydroponic gardens fed by Europa's water, laboratories analyzing samples from plumes that erupt from cracks in the ice, carrying ocean water up into space. Here, a small team of scientists and engineers could live for months or years, pushing the boundaries of human endurance and curiosity. But colonizing Europa will not happen overnight. The distances are immense, the dangers extreme. Before we can dream of permanent settlements, we'll need to master travel and survival on the Moon, Mars, and perhaps the asteroids. We'll need new kinds of spacecraft, faster engines, better shielding, and autonomous systems that can keep people alive for years at a time. It may be a century or more before humans set foot on Europa, and even then, only if the drive to discover outweighs the staggering costs. In the coming decades, as our robotic explorers send back more data, the picture of Europa will become clearer. We will learn which regions are safest, where the ice is thinnest, where plumes of water geyser into space, offering easy access to the ocean below. We'll refine our technologies, cryobots that drill without freezing, underwater drones that map the alien seafloor, habitats that recycle every drop of air and water, and systems resilient enough to withstand years in the cold and dark. And if, one day, we find even a single microbe in that endless, dark ocean, the implications will be staggering. It will mean that life is not unique to Earth, that the cosmos is teeming with possibilities. Europa could become the cradle of a new chapter in the story of life in the universe. So, the next time you gaze at the night sky and wonder about our future among the stars, remember Europa, the frozen moon with an ocean of secrets. The challenges are immense, but so are the rewards. Will we heed the warnings of science fiction, or will we dare to dive beneath the ice and discover what lies beneath? The answer, perhaps, awaits us in that distant, glittering world, a world that may hold the key to our greatest question: are we alone? If you've watched this far, congratulations! You are truly a passionate scientific explorer, always persisting and conquering every challenge. Let's subscribe to the channel so we can keep on discovering together.